Thank you, Thad, and thanks to Matt and Bill. A lot of really good insights, a lot of information covering a broad amount of topics. So we'll open it up for Q&A. If what we can do, we've got a microphone in the middle of the room here. If you have a question, please step up. We'll take them as they come, or if you can't get there or don't want to get up, no judgment, just raise your hand. I can repeat the question as needed. But figure, let me start it off here to the panelists. So there's been obviously a lot of different use cases, a lot of different battery sizes, a lot of different structures that you can employ. What should the folks in the room be thinking for utilities of all sizes, whether it's a muni co-op, IOU, public power district, or even at the commercial or residential level, maybe for Thad? What should they be thinking about if they want to dip a toe in the water? What might be the most cost-effective strategy, or what are the things that they should focus on first and foremost to dip their toe in, get the experience, and then maybe move to bigger or different applications?
I guess I'll take this one first. So that's an interesting question. One of the things that's been mentioned that we've actually partnered on was the United Power project, where we have essentially a community storage facility being commissioned in Colorado, and so Tesla is the battery supplier in that instance, and is partnered on that. I think that's an incredibly interesting structure for anyone who is a distribution cooperative, a way that you can essentially utilize storage to reduce your overall customer peak demand potentially, thereby reducing your entire wholesale bill. To me, it's a fairly fascinating thing to do. As far as dipping your toe in the water, first thing it takes is just getting the information together and gathering a small project to put in the ground, operate it, get the experience, and start there. I think SPP, we saw the 3,000 megawatt pipeline of wind coming in. Like, that pipeline for energy storage should be mirroring that, or at least certainly more than I can't recall, 3 gigawatts. It's kind of astounding, frankly, in today's day and age, where you've got intermittent resources coming online, to not utilize energy storage to make those more cost effective. And frankly, there's an opportunity there to, in my opinion, utilize those for more baseload resources.
Yeah, I think to Thad's point, ENGIE has a lot of experience working with distribution utilities, distribution cooperatives, public power districts, municipal utilities. And the interesting thing about energy storage projects at distribution system scale is, generally, by and large, you're not putting a project into an ISO queue and waiting for 2 years for the project to come out the other end. We can deploy these systems rather quickly at distribution scale and rather effectively. And so I would encourage those in the room who are interested in energy storage to talk to a developer, consultant. I'm sure anybody up here would be happy to talk to you about energy storage projects, even if you don't exactly know what you want to do yet. But I would say, try to think about, based on all the stuff that we've been talking about today, how do you think you can monetize an energy storage system? Do you have energy needs, capacity needs, transmission or distribution system upgrades that you're planning? Where do you think you might be able to use a battery? And then start talking to somebody about it. And they can help you flesh out the business plan. They can help you figure out the pricing. They can help you decide on the technology options and help you figure out the term and help you with the contracting and put a system in the ground. As much as there are folks who look at the price curve and want it to keep going down and sort of wait 2 or 3 more years every 2 or 3 years, at a certain point, you might get left in the dust a bit, and you might also wake up and find that a bunch of your customers or members on your system are doing it anyway and putting it behind the meter, and then you have no control and no say. So I will say, from a utility perspective, speaking to utility perspective, think about a pilot system and early deployment and start talking about it now.
Yeah, dip toe in the water. I think on the utility scale front of the meter side of things, start small. if there's some trepidation there. So, if there's if you're contracting 300 megawatts of wind or, 200 megawatts of solar or whatever, or higher values than that, start with a small project. And, I think what we've seen in other markets is that utilities, once they have storage on their system, they want a lot more because they see the benefits, and there's other uses and other use cases that become apparent, as the systems are deployed.
So I think the question was, are there things that could be done differently at a national level, or perhaps, I'm going to throw this in there, a local level, to reduce barriers to energy storage deployment? Is that fair? Okay. From a higher level, so utility planning has, over the past 100 years been fairly static, I would argue, and I have been a utility person in the past, so I will point that out, and especially at the distribution level planning. And as mentioned by some of the other folks up here, distribution level storage can actually be the low-hanging fruit. It can provide immediate benefit and cost deferment in a lot of cases. So, for example, if you are, you do have the benefit of having this, being public power districts, frankly, here in Nebraska, because when they're looking at distribution system planning and there's a feeder that they need to upgrade, rather than looking at the feeder and saying, okay, we need to replace this and invest X dollars, there is an opportunity there, an opportunity cost to essentially defer that with the use of energy storage, that upgrade. So there's some things in Nebraska that are unique that I think are benefits, but by and large across the United States, I think it is more integrated distribution system planning that would be kind of the first step in helping to address customer bills, reduce costs, or defer them.
Yeah, and I think one of the other parts of the question was, are there barriers or other challenges in parts of the U.S. and I'd say yes. And it's as Thad mentioned. I mean, it's hard to tell whether it's intentional or not. And have to dig into some of the details there. But in terms of process, I mean, one thing is that I know OPPD and NPPD did include storage as part of an RFP late last year. So, there's some pricing information that they requested. So I think that's good, good practice there. And then regarding IRPs, at a recent conference, saw, a chart of the U.S. in terms of states that have storage as part of the planning process. And I think it's either around 20 states in the U.S. now, 20 or 25 states that have storage specifically as part of the IRP process. So, I mean, I think to add to what Thad had said, just looking at it, I think is important, at least consider the option. The other thing is that current pricing is really important. So, storage pricing is coming down really fast, and there's been some high profile cases where costs that were, from 2015 or 2016 were used in planning. And, we've seen system prices drop 50% since 2015. So, the whole system is half the cost it was, 3 or 4 years ago. So, it's important to get current pricing and forward-looking pricing, during a procurement process. In particular, if you're looking at, let's say 2021 or 2022 COD, and you're using 2016 numbers, you're going to be off by a huge factor in terms of cost. So, I think that's an important consideration.
Yeah, I'd say in addition, what Matt pointed out, the FERC orders 841 and 845 are going to hopefully help push the ISOs to develop policy that will help developers, that will help the use cases and the costs, so bringing down costs and understanding what developers can do with the batteries, which will ultimately obviously benefit the customer.
I might tack on like a 5-second thing, which is just to bring it right down to this level. I know we're answering your question in detail. We've actually heard from some distribution utilities in particular, but it probably isn't exclusively the case with just distribution utilities, that even the software that they use to do the planning and modeling of their actual system doesn't accommodate storage very well. So go demand that your software providers do that, because there are different kinds of assets. They're not just generators. They're not just load. They're not just, so go demand that your software that you use to model your system and plan your system adequately accounts for energy storage.
Well, I'll keep going then. We talked about battery management a bit and touched on the importance. Obviously, figuring out the size and duration of the battery that works for the customer or works for the utility, whoever that end-use customer is, that's a big deal. But I would argue equally or maybe more important is how the battery is managed. How many cycles is it planning to go through in a given day or a given year? How are you dispatching that battery, set points on charging and discharging? Can you guys talk a little bit about what you're seeing in terms of battery management, what to hone in on, and really, I guess, Bill, to your structural slide, why would a utility or an entity want to own versus do a PPA? What are some of the things to think about on the pros and cons side of each?
I'll start with the last part of your question, and then maybe I can let others jump in on their editorial on the first part. In general, there are trade-offs between a third-party owned system and a utility-owned system. Some of the benefits of a third-party owned system are that developers can almost always efficiently monetize the ITC. So if you have a solar plus storage system or storage system as a retrofit on an existing PV project, there are sometimes challenges with especially cooperative or nonprofit utilities in being able to monetize the ITC, and so developers can often do that for you, and therefore it might be a better kind of option. In general, though, it isn't the case all the time that you either would want to take the ITC or that your use case would demand it, in which case it's certainly fine for a utility to own and operate the asset themselves and contract with a third party for operations and maintenance to the extent that they needed it. In those cases, the cost of capital of a utility are often lower than a third party developer. So in that case, it may actually be a benefit for a utility to own the system, provided that they do a good job of finding qualified integrators and third parties to kind of handle some of the complicated pieces of warranties and management and operations of the batteries, which I think leads us back to the first part of the question. So does somebody else want to take a stab at that? Integration, management, operations.
Yeah. So, I think this is a very good question, and we haven't, we didn't dive too much into the technical aspects of storage in this discussion, and in particular lithium-ion. So, as Adam indicated, lithium-ion batteries, they do degrade, and as everyone knows, with their cell phone and computer, and the cell technology that's used for utility scale projects is very similar to what's in your phones and computers, though there are quite a few. We could have a whole panel on the various alloys used in lithium ions. So they're not all built the same. They're slightly different in terms of their composition. But at the end of the day, there's some degradation that's related to cycling. There's some degradation that's related to some other things, resting state of charge. At the end of the day, a lot of it comes down to heat. So there's some heat that's generated, and that degrades the cell. So managing the cycling is important, and I think that is a consideration, both whether a utility wants to own the project or wants to contract a third party. Depending on the intended use case, there's probably some benefits to both. Obviously from a risk standpoint, if a utility is contracting third party, what's ever in the contract will be delivered, right? So, if we say we're going to deliver, 100 megawatts of capacity for this number of hours every day or during a seasonal aspect, we're contracted to do that, and sort of take some of the management of the cells and all that out of the utility's hands. Now, if there's some unique operating regimes that are hard to contract, there may be a reason for ownership. So I think there's a lot to this, and there's some important details. But all the panelists here, we're all involved in the business and trying to work with utilities and customers that have varying levels of expertise related to the technology.
I think it's important to note too that the contracting sort of style that you can employ in terms of it's paired with a storage system with wind or solar. You can do it on a dollars per megawatt hour basis. You can match it up or not match it up on the contract, but you can also do it in a dollars per kW month, sort of a capacity style basis as well. There's a lot of things that we can do as developers and that other battery integrators can do to make sure that the customer or the utility is getting what they want. Another question on the floor, yeah, please.
Oh, perfect. It does work. So I have two questions. One, what is the biggest cost driver in terms of driving down the cost of batteries? And do you see that leveling out in the next couple of years? And then the second one, Rob this morning touched on using thermal storage and like water heaters and then also electric cars as kind of a distributed battery storage option. Do you see that happening in the next 5 to 10 years, or is like utility scale going to be the way that we see in the next 5-10 years?
I'll answer real quickly on the first one. So cost drivers, I mean, batteries, battery is the single biggest component, especially for systems that are, 2 or 4 hour duration in length or longer. But, we are also seeing balance of system costs come down as well. So inverters, the racking, the enclosures, just the overall structure. So, similar to what we saw and are still seeing on the solar side of things. There's just more and more efficient building. And then also the other thing that's helping with batteries is energy density. So the amount of power and energy per, square inch or square foot is increasing with every generation of cell. So the systems are getting, smaller and smaller with the same amount of power. But I'll defer to the other panelists on number 2 there.
Do you want to talk about cars?
Sure, I'll talk about cars. So I think the question was about vehicle to grid. Is that generally right? Yeah. So and how to utilize essentially electric vehicles to help offset load that's being consumed outside of the vehicle. So as far as duration goes, I think it's going to be dependent on a whole number of things, partly policy, meaning when that time will come. Certainly there are a number of companies that are considering that. There have been projects in a variety of different places. California had a project where they utilized BMWs to essentially do a vehicle to grid and do demand response program utilizing 100 of their vehicles. It's in a phase 2 at this point. But generally, then I think we're probably at least 5 years away from any actual use of vehicles, and that's partly due to the deployment of EVs. We're going to see a lot more of them on the roads, but it's going to take a while to get there. And it'll be kind of pockets and locations depending upon how urban that area may be. It also is going to be dependent upon one of the other topics that was brought up earlier today, which was recycling and what are the effects of recycling, and does it make sense to utilize an EV during its life and then post life? Does it have a second life as a utility asset, or is that simply because we are trying to deploy and get more EVs into customers' hands? Does it make more sense to recycle it at that point and utilize those materials for new batteries? So it's a long answer for a question that's probably about 5 years out to see vehicle to grid start really taking off.
I'd like to thank our panelists, Matt, Bill, and Thad. Thank you very much for your time and for your insights. Appreciate it.